Dealing with an electrical fire in a manhole is something that we are all concerned with. One way of handling the fire in the manhole is to put water on the electrical fire. I am Tom Zaslak, a principal electrical engineer for the Boston Edison Company. Today, you are going to see 3 demonstrations. One demonstration will be the burning of old cable and new cable, and you will see that the new cable is less likely to continue to burn. The second demonstration will be a 15,000 volt fault. We'll do the fault in air and then in a bucket of water. We'll measure some voltages to show you that it's safe to make contact with the water when there's an electrical fault in the manhole. The last demonstration we're going to do is a 15,000 volt fault in the manhole, in which the electrical fault will set the manhole on fire. While the fault is there and the fire is burning, we will put the fire out with the hose. This is the first demonstration. The first cable we have here, this is a paper and lead cable. These papers are saturated with oil, and what you're going to see how it burns readily. The second cable you see here, this is a fire-resistant cable, and this, when fire goes to it, wants to go out right away. Kurt, we're ready to set the cable on fire. Okay, that looks good, Kurt. Looks good. Looks like it's going to go by itself. I think we can take it off now. Now, as you can see, the paper tapes and the oil saturated, it wants to continue to burn. One of the things that happens as it continues to burn and burns its way back, it'll eventually come to the point where it melts the lead and the fire goes continuously from manhole to manhole. Okay, Kurt, I think we can put it out now. We have replaced the old cable, the paper and lead cable, with the new fire-resistant cable. We'll now see how well that burns. Now this is about the same length of time that we had the paper and lead cable on. Now, Kurt, if you take that away, let's see if it continues. Now you notice the flame is getting smaller and smaller and finally goes out, whereas the paper cable continue to burn along the length. Okay, let's try it once more, Kurt. Let's. Now we're burning it even more, a little bit more intense. We'll see if we can't get it going. With the flame on, it wants to burn. Now we take the flame off, and again, it wants to go out. In summary, the old paper and lead cable wants to burn, whereas the new cable that we install in manholes today does not want to burn. This is the second demonstration. This is going to be a 15 kV fault. In order for us to do this demonstration, we're going to use this portable transformer, which will become energized by a generator. The transformer is going to take 120 volts and boost it up to 8,000 volts. In order for us to measure that voltage, to see if we truly have 8,000 volts, I'm going to use this 1000-to-1 probe. The 1000-to-1 probe is going to be placed on the conductor of the cable and to the ground that wraps around the cable. What I'm going to do is step away here to one side and ask Dennis to energize the transformer. The voltmeter now reads 7.93. That's a 1000-to-1 probe. That means we have 7,930 volts on the conductor of this cable. Now with 7,930 volts on the cable that we've energized with the transformer, I can take and pick up this cable without fear of electrocution because the cable is grounded. Dennis, kill the generator. Now as we look at the meter now says it's 0.000, which means the generator has shut off the transformer and now the cable is dead. Now that we showed you that we have 7,930 volts on the conductor, we're going to take that voltage, put it into this cable that has a fault. Okay, Dennis, energize the cable. Now the fault is jumping all over the place as the fault will do, but the voltmeter, instead of reading 7.93 as you saw before, is only reading 0.2 in this case. That means we only have about 200 volts or 150 volts. Okay, Dennis, kill the generator. Now we're going to fill up the bucket with water, and we're going to measure the voltage that's inside the water. What we have here, we put in two probes. The first probe, the black probe, is set 6 inches away from the fault. The red probe is set 12 inches away from the fault. And what we're going to do is, with this meter, we're going to measure the voltage in the water between the water and ground. Okay, Dennis, let's fill up the bucket with water. Now that we've filled the bucket with water, we've attached a meter to the two probes. This is a regular meter. There is no multiplier on it. It's reading directly. Okay, Dennis, energize the fault. With the fault in the water, the meter is measuring the black probe, which is 6 inches away, and it's measuring about 5 to 6 volts. Okay, Dennis, could you change it to the red probe? Okay, the red probe is measuring 4 to 5 volts, 12 inches away. I'm now going to take the ground, attach it to my wrist. I'm now going to put it in the water. As you can see, with my hand in the water, there is no danger of electrocution. We have just shown you a fault in air and in water. The fault in water is a solid body of water in which I put my hand in the water 12 inches away from the fault, and there was no danger of electrocution. This is the third demonstration. The 15,000 volt fault that you saw in air and in water, we now have placed inside this manhole. We're going to take the transformer that we've used already to energize the high voltage cable. We've connected it to another high voltage cable, the adjacent manhole. We're running that high voltage cable into this duct so we can energize the fault. When the cable gets energized, the fault inside the manhole will set the debris on fire. When the fire is going, I will approach the manhole with water coming from a garden hose to put out the fire. Dennis, energize. You can see the fault and that it is slowly beginning to set the debris on fire. When I begin to put the fire out, I will not stand directly over the manhole. Instead, I will approach it from a distance and spray the ground ahead of me as I get close to the manhole. I'll spray inside the manhole as I get closer to the opening. You should never stand directly over an open manhole that's on fire or smoking, in case there is a sudden explosion. Okay, now that I put the fire out with the water, The arc is still going. It's a lot of smoke right now. We're not going to see too much. Dennis, can we measure the voltage? We're going to measure the voltage. I can't see the fault. There's so much smoke. What kind of voltage are we getting, Dennis?
Around half to 3/4 of a volt. Even less.
Even less? This fault is about 6 feet away from the fire.
Not even a tenth of a volt.
There's so much smoke, I cannot see the fault. Again, the only thing we've done here is to show that with a live 15,000 volt fault, with all this smoke and fire, I can still hold my hand on the hose. I'm stepping on a metal grounded manhole cover, and I'm measuring very little voltage. A lot less than what we had when the fault was in the bucket of water, which I had around 5 volts. I'm only measuring 1/10 of that. I'm only measuring about 0.05 volts. What we just showed you is that a 15,000 volt fault in a manhole with trash burning and the fault still active and the cable energized, you can put it out with a hose, with water, even as simple as a garden hose. Now that you've seen the 3 demonstrations, I want to talk about why is it safe to go into manholes. And it's safe to go into manholes without being electrocuted because of grounds and grounding in the manhole. The cable that you saw outside that we set on fire was a paper and lead cable. This is lead that is a grounded for the cable, and this now becomes a safety ground for anyone entering the manhole. These are the paper tapes that we set on fire. We're going to replace the lead cable with this new cable, and this is a high voltage rubber cable. This too has a safety ground on it, but in this case, this is copper. Again, it wraps itself completely around the high voltage conductor. Also out in the field, we have plastic cable. This too has a safety ground that wraps itself entirely around the conductor. This is a tin copper ground. Now, when these cables are brought into a manhole, they have to be joined together. This is a paper lead cable joint. We have paper cable coming in on this side and paper cable coming out on the other side. This is a lead joint that's used to surround the cables with a safety ground. This, on top of it, is you see a ground bonding wire that we attach to a ground bonding frame in a manhole. Down below is a larger joint. This larger joint also has a safety ground on it, but it's a larger conductor. Down in the back is a joint made up with arc-proofing tape, and that is to reduce the fault from causing the joint to fail. On the top rack, we have a rubber cable joint. This too has a safety ground that's brought out. In front of it is a plastic cable. It too has its safety ground brought out. Let's go into a manhole and look at the grounding inside the manhole. As you can see, we are in a typical manhole. Behind me are some ducts with cables coming out. Up on top is a 120 volt cable, down below is 15,000 volt cable. On each side are racks of cable. This is a cable that has a joint in it with the ground coming out. Down below we have some lead cable. They also have grounds coming out. All of these grounds are attached to a common ground bond frame that runs in the manhole. It runs around the manhole, joining all the grounds together. Depending on the manhole you're in, there are different types of high voltage equipment, such as a high voltage transformer or a high voltage switch. This is a high voltage switch. It has 3 grounded high voltage cables coming in on one side, and the switch itself is grounded. On the other side, we have the same. That makes a total of 8 grounds on this one high voltage switch. A high voltage transformer has just as many grounds on it. Now, a question you may have, what happens if the ground blows free when a joint fails? Is the cable still grounded? The answer to the question is yes. This cable is coming from another manhole in which is grounded in that manhole. The cable on the other side is going to another manhole and it's also grounded in that manhole. And that concludes our demonstration for today. What we've shown you is that it is safe to go into a manhole with all the cables energized. It is safe to put water on an electrical fire in a manhole. It is safe even to put water on an electrical arcing fault. There is no danger of electrocution. Thanks for watching.